Welcome to this explainer. Today, we're pulling back the curtain on the invisible digital machinery that's quite literally running the smart cities of 2025. It's a fascinating, complex, and honestly, kind of daunting world. We'll be using Professor Hatem El-Aidhi's compelling research on smart city governance as our guide. Together, we're going to explore that super delicate balance between incredible urban efficiency and the unseen risks to our data, security, privacy, and ethics.
Okay, let's dive right in. To really wrap our heads around this, we need to establish the sheer, mind-boggling scale of our urban pulse. Smart cities are projected to generate a staggering 181 zettabytes of data by 2025. I mean, just try to grasp that number for a second. This astronomical volume of information is literally the lifeblood required to drive this unprecedented utopian level of efficiency in our daily lives. Everything from how our traffic flows to exactly how our power is managed.
But, well, here's the surprise pivot. With all that incredible efficiency comes a massive, unseen target on our backs. The data shows 820,000 Internet of Things, or IoT attack probes happening every single day. And these aren't just random glitches, right? These are active probes targeting critical municipal lifelines, specifically our energy and water infrastructure. It immediately sets up the high-stakes reality of the modern connected city. To peel the onion on this complex topic, we're going to explore four clear layers today. First, the urban nervous system. Second, the city data lifecycle. Third, the privacy illusion. And finally, the cyber battleground. Let's jump straight into our first two sections, the urban nervous system and the city data lifecycle. You can think of this as the hero's journey of a single piece of city data. Every bit of information in this urban nervous system goes through four strict mechanical phases. From the very second it's generated out in the physical world, to how it's processed, to the actual benefits it provides, all the way down to the very real struggle of safely disposing of it when it's no longer needed.
Starting with generation, this really illustrates how different municipal sectors use specific sensors to constantly digitize our physical world. Think about mobility. We've got real-time traffic flows and public transit occupancy sensors. For utilities, smart meters are out there tracking every single drop of water and watt of electricity consumed. And for the environment, localized sensors track air quality, noise, and weather. We are quite literally mapping our physical world into digital data every second of the day.
Now, once that data is generated, it has to be processed, and cities rely on a hybrid standard here to ensure everything is resilient. On one side, you have edge computing. This happens right at the source for split-second, low-latency decisions, like, changing a traffic signal to prevent an accident. On the other side, we have cloud architecture. That's your centralized repository for massive historical analysis and cross-departmental insights. Both are absolutely essential.
Then we hit the utilization phase, and this is where that processed data delivers those utopian benefits we all want. The insights are just incredible. We're talking predictive maintenance, literally identifying infrastructure fatigue before a bridge or a water pipe fails. It means resource optimization, like dynamic street lighting and highly efficient waste collection routes. And crucially, it vastly improves public safety by optimizing emergency responses and health monitoring. It's a real game changer. But the journey doesn't end there. Finally, we reach disposal. This phase is governed by strict rules like GDPR Article 5.1e, which mandates that data be kept identifiable for absolutely no longer than necessary. Cities have to use automated purging and cryptographic erasure to prevent liabilities from what we call zombie data. And much like real zombies, if this unpurged data comes back to life past its lifespan, it becomes a massive, terrifying legal liability for the city. So it's a critical, yet often overlooked part of the whole shebang.
Shifting our tone a bit, let's move right into Section 3, the privacy illusion and governance.
Balancing the lure of surveillance capitalism with ethical mandates, like the EU AI Act, is now a strict legal requirement. Cities have to adhere to core GDPR principles. For instance, data minimization means collecting only the specific sensor data actually needed for a city's service. Purpose limitation ensures that your traffic data isn't suddenly sold off for commercial advertising. Accuracy guarantees your utility billing is correct, while accountability forces cities to document exactly where all this data is flowing.
Enforcing those principles, though, incredibly difficult. And why is that? Well, because municipalities often rely heavily on international tech giants to build their infrastructure. This creates severe data sovereignty risks. Cities face vendor lock-in, basically getting trapped in the single company's ecosystem. They face cross-border flow violations when citizen data gets stored on servers in other countries. All of this creates massive jurisdictional conflicts over who actually controls the city's nervous system.
And if you're sitting there thinking your data is totally anonymous on those servers, let this terrifying statistic sit with you for a minute. Research shows that just 4 spatiotemporal points from a mobility dataset are enough to uniquely identify 95% of individuals. That completely shatters the myth of anonymization. It means it literally only takes 4 places you visited today, say your house, a coffee shop, your office, and the grocery store, to mathematically unmask your exact identity. No way around it.
So the crucial takeaway here is that true anonymization is really just a moving target. As computing power rapidly scales up, what we considered completely anonymous yesterday can easily be decrypted tomorrow. Because of this, surveillance rightfully remains the primary driver of public distrust when it comes to urban digitalization. The fear of an ever-watching city? It's not paranoia. It's rooted in mathematical reality.
Which brings us to our 4th and final section, the cyber battleground. Take a look at this everyday technology. We've got intersection sensors quietly mapping real-time traffic to keep cars moving smoothly. But these mundane connected streetlights and cameras represent the urban edge. Because they're connected to the broader network, if they are left unsecured, they can actually be hijacked by external forces. And we're not talking about some theoretical sci-fi scenario here. Look at this number. In just the 3rd quarter of 2024 alone, there were a staggering 8.3 million DDoS attacks. And the weapon of choice? Weaponized smart devices. The very sensors that were meant to make our lives easier were literally turned into an army of digital attackers. Bad actors actively exploit simple, unsecured environmental cameras and sensors to create massive IoT botnets. They're hijacking the city's own infrastructure and turning it into a distributed weapon against itself. A compromised network of smart streetlights could, theoretically, be used to overwhelm and take down a city's critical networks, or even its power grid. It is a profound security vulnerability, and it's hiding in plain sight on practically every street corner. To wrap up this explainer on Professor Alaidi's research, we're left with a vital question we all have to face. How do we responsibly govern this transformation? Is the utopian efficiency and convenience of a fully connected smart city truly worth the ultimate surveillance capabilities and those severe cybersecurity risks we've explored today? It's a massive challenge, and it's absolutely going to define the future of our urban existence. Thanks for joining me, and keep questioning the world around you.